See Standard 12th Maths Chapter 6 Applications of Vector Algebra Exercise 6.5. See, before start doing the problems in the exercise, let me give you some introduction. Coplanar. Two lines are said to be coplanar if they lie on the same plane. So let me take the first line as vector R is A plus T into vector B. Vector R is equal to C into C. Here, let me take the vector, same parallel vector, because the two lines are parallel. We say the two lines are parallel here. So in that case, both the lines are parallel to the same vector B. Or they may intersect also. If they lie on the same plane, the two lines may intersect also at a point here, at a point O. So, what do you say about the distance between the two parallel lines? The distance D is equal to vector C minus vector A. We take C from the second line and vector A from the first line cross B vector, because both the lines are parallel to the same vectors. They are parallel lines actually. So divided by modulus vector B. Modulus, you have to take modulus for this also. So then modulus vector B, where this parallel vector should not be equal to 0. So this is the distance between the two parallel lines. Second concept is skew lines. Skew lines. What are skew lines? If they lie on different plane. See, in your book, you take the left side page and the right side page. Two different plane. So here I have one line. Here I have one line. So let me take L1 and L2. So in this case, they never be parallel. Neither be parallel nor be intersect. They neither be parallel nor be intersect. They lie in the different plane. They are not coplanar. They are coplanar. They lie in the same plane. They lie in the different two planes. They are not coplanar. So skew lines are neither be parallel nor be intersect. So when you find the distance between these two lines, let me take distance D. D is equal to, so in here we take the line because they lie the two different plane. So let me take here parallel vector B, and for this parallel vector let me take as D vector. So vector R plus T into vector B, when vector R is equal to vector C plus S into vector D. So two different lines, they lie in the two different planes. So distance, let me mark it as some delta. Delta is equal to vector C minus vector A dot B cross D. B cross D, take modulus for this, divided by modulus of B cross D. See, either this denominator term B cross D should not be equal to 0. So this is the distance between the two skew lines. So using this, let me do the sums for you. See the second sum first. Show that the lines vector R is equal to 6i plus j plus 2k plus s into I plus 2j minus 3k. First line. Second line, vector R is equal to 3i plus 2j minus 2k plus t into 2i plus 4j minus 5k. Are skew lines, and find the shortest distance between them. So I am going to show these two lines are skew lines. So what are skew lines? We say neither parallel nor be intersect. So first let me show this two lines are not parallel. So in that case you take the parallel vector of this first line, that is vector B is equal to, let me write the parallel vectors. parallel vectors. Line 1, first line, vector B is equal to I plus 2j minus 3k. And for the second line, line 2, vector D, parallel vector D is equal to 2i plus 4j minus 5k. So look at these two parallel vectors. If I want to show these two lines are parallel vector, one can be represented as some scalar multiple of the other. One vector can be represented as the scalar multiple of the other. See, look at these two vectors. Here we cannot take any common factor outside. Any common factor outside. So I cannot write these vectors as scalar multiple of the other one. So therefore, the two vectors are not parallel vectors. So we write that vector B is not a scalar multiple of the vector D. Therefore, vector B and vector D are not parallel vectors. First concept. See, next concept we have to show they do not intersect. How to show they do not intersect? See here, so this is the distance between the two lines here, and you just look at the numerator term. So this numerator term should not be equal to 0. The dot product of vector C minus A dot vector B cross D should not be equal to 0. So let me find vector C minus vector A. So what is vector C? Vector C is equal to, here the second line one, 3i plus 2j, 3i plus 2j minus 2k. Minus A vector is here 6i plus j plus 2k. Just subtract this. 3i minus 6j, that is minus 3i. 2j minus j plus j. Minus 2k minus 4k. This is vector C minus A. Take B cross D. Vector B cross vector D. How to find the cross product of this? I, j, k. See, vector B is the first parallel vector. I plus 2j minus 3k. That is 1 minus 2. 1 plus 2 minus 3. Next is vector D. 2i, that is 2, 4 minus 5. So you find the cross product here. So I into, leave off this column, minus 10 minus 12. So you will get plus 12. Then minus j into minus 5 minus 6. So plus 6 plus k into 4 minus 2 2s are 4. So you will get here 2i plus 1. So minus j 0. So no k vector here. So you have to find the modulus of this. Modulus of vector B cross D, that is square root of 2 square plus minus 1 square. Sorry. So this is the denominator one. Sorry. Just you keep this. Next you find the vector C minus vector A dot vector B cross vector D. What is C minus A here? Minus 3i plus j minus 4k dot 2i minus j. So take the dot I. So minus 6, then 1 plus 1 minus 1 is minus 1. Here no k vector here, so you will get minus 7. So you take the modulus of this. So actually this is not equal to 0. This is not equal to 0. Therefore the lines do not intersect. Lines do not intersect. You have to find just the numerator term. Therefore, see, already we have shown the lines do not parallel or not parallel vectors, and also they do not intersect. So therefore the lines are skew lines. Skew lines. So find the distance between the two lines here, skew lines. Vector C minus vector A dot vector B cross vector D modulus divided by modulus vector B cross vector D. See, already you have got this dot of this, and denominator term, see here, B cross D this. So what about the modulus of vector B cross vector D? Square root of 2 square plus minus 1 square. 2 squared is 4 plus 1, this is 5, root 5. So here B dot, so C minus A dot B cross D is minus 7. So modulus minus 7, just now we have got this is root 5. Modulus of minus 7 is 7 root 5. 7 by root 5 units. So this is the distance between the two skew lines here. Same model sum, I am going to do the fifth sum for you. See the fifth sum, show that the straight lines x plus 1 equal to 2y equal to minus 12z and x equal to y plus 2 equal to 6z minus 6 are skew lines, and hence find the shortest distance between them. See, the two lines are here the Cartesian form. You have to bring this in the Cartesian form, x minus x1 by x2 minus x1. Let me take the first line, x plus 1 equal to 2y equal to minus 12z. See, the coefficients of here x, y, z should be 1 here. See, already x coefficient is 1, but here y coefficient is 2 and here z coefficient is 12. So take LCM for 2 and 12, you will get LCM is 12. So divide each term by 12. We need the denominator term. From this we can get the parallel vector direction ratios by 12. So y by 2 by 12, that is 6, and then z by 12 you will get 1. So this bring this minus here in the denominator. This is minus 1. So here the point and then parallel vector you have to collect. Before that you take the second line, x is equal to y plus 2 is equal to 6z minus 6. Here x equal to y plus 2, 6 common, z minus 1. So here the coefficient of x is 1, coefficient of y is also 1, but here we have the coefficient for z as 6 here. So I divide each term by 6. By 6, y plus 2 by 6. Here z minus 1. 6 by 6 is 1. So let me collect the point and also the parallel vector. See here the point here is x1, y minus y1, z minus z1. Here x minus x1 form. See, x minus x1, x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 by z2 minus z1. So the denominator are given the direction ratios. They are the components of the parallel vectors. And here x minus x1, y1, z1 are the points. So you write the first point from the first line, vector A. So here plus 1, it should be of minus 1. So you will get minus 1i, and no j vector. See, no term here, y minus 0. This is z minus 0. So you will get vector A is minus 1. And what about vector C here? Point you will get from the second line. So x minus here, so 0i. But here plus 2. So minus you have. So minus of minus 2. So minus 2j. So already it is minus. So plus vector k. These two are points. And what about the parallel vector? Vector b is equal to denominator. They are the components of the parallel vector. Direction ratios we say 12i plus 6j minus k vector. And vector d. So denominator of the second line 6i plus 6j plus k. And look at the parallel vectors here. See, we cannot write them as the scalar multiple of the other. We cannot write vector b as the scalar multiple of the d vector. See, we cannot take the common factor also here anywhere for both the vectors. So therefore from this, so the lines are not parallel. Lines are not parallel. Not parallel. Next we have to see they do not intersect. For that, the previous sum, first we have to find vector c minus vector a. So what is vector c? Minus 2j plus k vector minus a vector. So minus I. So minus into minus plus I minus 2j. See, minus into minus plus I minus 2j plus k vector. And what about vector b cross vector d? So determinant form here I, j, k vector. So write vector b. Vector b is 12, 6 minus 1. 12, 6 minus 1. Vector d is 6, 6, 1. So this is equal to vector I is equal to, leave up this column, 6 ones are 6. 6 minus 6 is plus 6. Minus j vector 12 minus 6. So plus 6. Plus k vector. For j you will get minus. 12 6 are 72 minus 36. So here 12i plus 18j plus 36k vector. So find the dot product of vector c minus a dot vector b cross vector d. So what is c minus a? You got I minus 2j plus k dot 12i plus 18j plus 36k vector. So I with I, 1 12s are 12. So minus 36. 1 minus 36. Sorry, 1 plus. Sorry, this is plus. 1 plus 36 plus 30. See, sorry, here I made one mistake here. This is actually minus here. Minus. So you will get here also minus 12i minus 18j. So in that case, minus into minus plus. 1 into 36, 36. You all add all the terms, 72, 84. So this is not equal to 0. So the lines do not intersect. The lines do not intersect. Therefore, the given two lines are skew lines. Skew lines. Now let me find the distance between the two skew lines here. So delta is equal to, formula is delta equal to modulus of vector C minus vector A dot vector B cross D divided by modulus vector B cross vector D. So what is C minus A dot D? You have, this is 84. See, what about B cross D? So this is your B cross D. So find the modulus of this B cross D. Here you have 6 as common here. See, 6 common. I can take outside. So in that case you will get 2i minus 3j plus 6k. So modulus of B cross D. So that is, you can just keep this 6 as it is. Just let me find that. Modulus B cross D is equal to 6. Keep 6 outside. Outside here 2 square plus 3 square minus 3 square plus 6 square. 6 outside. 4 plus 9 plus 36. This 6 into square root of 49. 6 into 7, this is equal to 42. Substitute in delta. So numerator you have 84 divided by 42, that is equal to 2 units. So this is the distance between the two skew lines. So nothing here, just you have first step showing parallel and take, they do not intersect. In that case you take the numerator terms in the distance formula and substitute the distance formula. Thank you.